I'd like to call the April edition of the San Diego DX Club meeting to order. We'll start off with the pledge to the flag. I'll have Jerry lead us. Okay.
Ready, begin. I pledge allegiance to the flag of the United States of America and to the
republic for which it stands, one nation, under God, indivisible,
for all.
with liberty and justice for all.
Thank you.
Great. We have the pleasure of having Bud, our Vice President and Program Director, as our lecturer tonight. And he has an interesting topic for us. He'll tell you a little bit about why he chose this topic. So, Bud, it's all yours.
You want me up there, Jerry, or you got it from there? Okay, perfect. Okay, so can everybody hear me online?
Yep.
Okay. What's that? Oh, okay. Yeah, only the Zoom people hear it through the mic. So I'll just have to bark it out louder in here. Anyway, y'all know me, I'm Bud, AE6BH. And as we'll see in the presentation here, I'll explain why I'm doing this presentation, how it came to be. But I just had I acquired an interest in lightning protection recently. Oh, well said. So I guess we'll go ahead and kick it off. To go to the next slide there. So we're going to cover tonight understanding what's involved with the risks of lightning protection or lightning and on ham radio antennas, and then how you can implement protection and what protective hardware and installation techniques there are, and then some best practices. Just a disclaimer, a lot of this presentation was done by AI. It was fascinating. If you remember, a couple of months ago, we had an AI presentation, and I got interested in that and started playing with it. And this entire original presentation was created in about 5 minutes by Microsoft PowerPoint, just telling it to create me a presentation on amateur radio antenna cable lightning protection for HF operations. And in about 5 minutes, it generated 40 slides. Now, 40 or 50% of them were utter garbage, but that's okay. The core of the outline was there, and you could build upon it and throw away the junk and add in some other stuff that was real. But even generating new stuff was mostly done by creating AI queries I used primarily the Google Gemini AI, asking it for information about how to create a graphic to do this or a table to do that. And it did it. And it was often wrong, but it was okay. You could guide it. No, I don't want it to look like that. I want to add this data and get rid of that. And it's supposed to be a transient response, not a DC response. And it was modifying the graphics on the fly as we went. Very cool. From an engineering perspective, from my if I was still working in engineering, I would be having a ball with this stuff. The Microsoft Copilot. Yeah, this is, I mean, if I was still working and not familiar with AI, I'd be worried. Yeah. Honestly. So I'm glad I don't have to worry about that. Just have fun with it. So I did try to use the
Why are you going to need engineers to check the hallucination?
Well,
and the garbage.
You like any simulation software, you really have to know garbage in is garbage out. So you've got to know the answer kind of before you ask the question, but you can let this tool do the legwork, and then you can fix it or ask it to fix it, which educates it even more. So, okay, next slide. So we've already covered what we're doing here. Let's move on. Before we start, how many people in the room here and online have an antenna connected to their radio and it goes into their house? Okay. Ham Shack. Next slide. Okay, next slide. Who has any form of lightning protection on their antenna cables? I'm impressed.
Power strips count?
Well, on the antenna cables. Coming off your tower. Indeed we are. And blessedly so. Okay, so
I have a question.
Yeah.
Are the other Zoom guys seeing the presentation? Oh,
yeah.
okay, I'm not. Okay.
Did you share the screen, Jerry?
They're seeing it, I'm not. So I gotta figure out what's going on. Thanks.
Can
Sorry.
everybody else online on Zoom see it?
Yes, I see it. This is AI60.
Okay. It's my
Okay.
problem. I'll figure it
Yeah,
out.
yeah, you gotta click that view icon up there on the top right.
Okay. All right, let's go to the next slide. So as why this presentation now? Well, a few weeks ago, we had a thunderstorm in Escondido around 3 a.m, which we were loving the rain and happy to hear it coming down. Oops, presentation went away. There it goes. Around 2 or 3 a.m, as I recall, I was sound asleep. There was a loud crash, deafening, that set off all the automobile alarms in the neighborhood. Everybody's house has got a car parked in front of it, honking away, lights flashing, and everybody's up running outside to see what's going on and to click their keys to shut their car up and looking around to see what got hit. Well, thankfully, we couldn't see anything that had been hit, and I didn't have any damage that was obvious, but it sure rattled my cage. Anyway, I took it as a wake-up call because I don't know how far this thing was away, but it was real close. And so I thought I'd dig into trying to understand what could be done for lightning protection. And AI has been a really fun tool to use about the dynamics of lightning and grounding. Okay, Jerry? Yep. Okay, sure. Hey, can you guys all see it online now?
Still seeing it here.
I'm reading.
I'm seeing it now. Operator error.
Okay. Okay, we can go to the next one. So there's the basic concept of how a lightning strike works is a charge builds up as clouds form, and also a static charge starts to accumulate on your antenna or on trees and things as a result of the storm. Shortly after, a leader forms and starts to come lightning coming down from the sky, and eventually it attaches with an upward strike from whatever has a opposite charge on the ground. Could be your antenna, could be a tree, a local tower building. The two connect, and then the big return stroke starts and the big transient surge. And that all takes place in a few microseconds. It's fast. So it's up in the megahertz range in terms of transient. And obviously the currents are huge in the order of 10 to 30,000 amps. So, okay, Jerry. I found a neat graphic. Yep. That this was a graphic that was actually created by AI in response to a question of create me a graphic that shows the anatomy of a lightning strike with its timing and frequency content. And this is what Google produced for me in about 30 seconds. I had to ask it to fix a few things because there were typos in it, and there's still a couple of typos if you look closely enough, but it's still pretty impressive, I think. But you see the time at the top is in milliseconds, the total time frame. So in the first 150 milliseconds, you get these charges trying to descend at which time they connect at about, 2/10 of a second in, 200 milliseconds. And then in around half second time, the next of it, the main strike and then subsequent strikes occur, and out to about a second when it's all over. The frequency content of a strike emitting noise as high as a gigahertz. As you can see in the very bottom, the current waveform striking of the first strike has about 1 to 2 microseconds for the first peak. And then this decay. And then you get the subsequent in 40 microseconds later, some other continuing current. So it's a pretty dynamic situation, as would be obvious for lightning. Now, some good news. We live in San Diego. We're lucky in a lot of ways, except for gas price. In the USA, San Diego County is the lowest incidence of lightning in the entire country, with roughly 1 strike per square mile per year, as compared to Florida, which is more like 20 plus strikes per square mile per year. So we're pretty blessed here in terms of lightning, and it also makes you wonder, do we really need to do anything? Or are we happy with that low risk already? I was curious and I dug and dug for any kind of studies that might say the incidence of lightning is increasing in San Diego County. It sure feels like it to me. I seem to feel like I hear more lightning in years than in years past. But despite all my digging, I could find nothing of any verifiable, studies that confirmed that. So it really seems to be that there's been no significant change. There's some different years have a little more than other years, but it's just anomalous the whole way through. There's no trend to any of it. 2020 was a big year. 2024 had some. 2018 had a bunch, but there's nothing. If you look at the spread of the rise and fall of lightning incidents in San Diego County, it's just a noise. It just varies up and down a little bit from its normal. I think it's on the order of 5 or 6 lightning days per year that we experience. Okay, Jerry? So how lightning affects your systems, outdoor antennas can bring that strike or nearby strike. It'll couple into your feed lines, couple onto your antennas. Lord help you if you get a direct hit. Nearby strikes induce transients and find their way down your cables and into your house, possibly damaging tuners, connectors, receivers, radio, front ends. Everything can be zapped by that. So it's how it might actually manifest as far as damage is anybody's guess, especially on the more modern radios. Old tube radios, probably until it gets into the very high voltage range, probably don't really care much. But a brand new, several $1,000 SDR sitting on your bench with the antenna connected straight to the A to D converter, probably not going to like it much. Okay. According to this one statistic here, that 70% of lightning strikes or failures are caused by director induced and damage circuit boards and connectors, and repairs can reach into the thousands of dollars. And any kind of effective, any kind of lightning protection dramatically reduces that risk. So, okay. So grounding, from everything I've read, and if you go back to years ago, Howard White's presentation on creating a quiet station, he did a lot of talking about grounding in his system and how important it was to having quiet radio. But it's ground for quiet station and ground for lightning, two different cats. but they must be connected together for a common ground, and to make sure that one ground, your lightning ground, doesn't have a chance to rise above your station quiet ground, house ground. Or if the lightning is going to elevate your local lightning ground, you want it to elevate your house ground with it, so they ride up and down together. You can go back. Choose the backspace or the basically, so you want to have, with grounding, you want to have a super low resistance path to safely dissipate surges and protect your gear. There's ways to improve your ground. San Diego has notoriously bad ground in general, with all of its decomposed granite and dry soil, especially inland where it gets warm and dries out the ground. And so your standard ground rod in the ground may or may not do anything for you, unless you can get a bunch of them in deep. The soil performance will vary with the soil and soil moisture. And then as time goes on, you got corrosion problems with grounding and soil drying out that can degrade the ground performance over time. Okay. So there's a lot of details that matter getting your ground. As I mentioned before, ground rods, often multiple ground rods, are what's needed. I know Howard had mentioned he put 3 ground rods in about a foot apart from each other and had them all somehow connected together with copper pipe. I'm not sure whether he soldered them to the tops or exactly how he bridged them all together, but it was they were very well tied together, is one way. In the rocky poor soil that we have here, other techniques such as burying copper pipe. I happen to have about 20 sticks of 3/4 inch copper pipe sitting in my barn that I went, oh, maybe I'll use that and I'll bury that because it's just sitting out there collecting dust. Maybe I can build a ground array and put it down in the ground near the outside of the shack and create a grid or whatever. I happen to have it all tied to a cold water feed pipe. It's about 150 feet long. That works great. And then my household UFER, which is your ground concrete slab ground that most houses that are built on a slab have these days, which I never thought much of a ground UFER as being considered a good ground, but it actually is considered an excellent ground, and especially for quiet ham radio operation. So that kind of took me by surprise in doing this digging that I was doing. The UFER is in a concrete slab house. You've got rebar, and all that rebar is stitched together and comes to a common point that sticks up out of your slab somewhere, usually close to wherever your power mains, service panels at, and is tied up to the service panel. It happens in my shack that it's directly behind the bench that my ham radio gear is tied to, and directly by the power panels on the other side of the wall of the garage. One of the surprising things, and I learned this years ago when building my shack, was the UFER quite often is just a piece of rebar sticking out. Electricians have a habit of just putting a clamp around it and running the wire up to the power panel. The problem with that is they haven't very often cleaned off the UFER rod to get I call it the slag, the hard coating off of the rebar, which is very non-conductive. They got to grind that off with a die grinder or something to get down to bare steel, then slather it up with good anti-oxidizing compound like Noalox or something, and then clamp to that. And I clamped both of those to my copper feed pipe for the cold water. And UFER.
It must be an acronym.
It's not. It's a person's name. Yeah. 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 And it's been being done for quite a long time. It's not a new thing at all. So the other thing that can be done once you've put if you play the game of putting kite pipes or something in the ground, is that again, you can use soil amendments. And what I learned is one's called bentonite. What it is, I don't know. Some kind of clay. And you mix it with sand and you put that in. Since you've already dug a trench to put your pipe in, you just buy the stuff, a few bags of it, and you backfill with a mixture of bentonite and sand, and it will improve the ground. Then there's the bonding techniques, how you tie all these together. Solder, like typical lead-based or no lead, electronic solder, no bueno. In a lightning strike situation, it's going to overheat and it's going to melt and come apart. Is what the big worry is. So what's recommended is that you do something like silver solder or CAD welding or something like that to bond the materials together, not just conventional lead-based solder or low melting point solder. The other thing, when you're routing the cables, lightning does not like 90-degree turn wires. If you're coming down off the chimney or off your tower and you want to get to the ground and hang a 90-degree turn, don't do it. Keep all of your cables with long sweeping turns. They mentioned 8-inch or greater radius on all turns. And then testing your ground resistance at your house and your electrical ground resistance. And that's not something that most people have a tool to do. You can't just take your ohm meter out and jab it in the ground to get a number. The common method, I probably should have shown a slide on this, is to have a pair of probes that are about 10 feet apart, and then another pair of probes in the middle of them, and you pass a fixed current between the feed and the source, the feed and the return probe, and there's a differential voltage measurement made in between the two, 4 probes spaced equally in the ground. That's one method, but there's also some electromagnetic probes that just clamp onto your ground wire. Not really sure what the science is behind that one, but they can just measure without any kind of other connections. And in looking around the internet, most of these machines are $1,000 or more to measure ground resistance. But on eBay, there's a lot under 100, and some even the $30 or $40 range from China that can be had to at least give you a number that's perhaps useful to measure changes. Might not be NIST traceable numbers that you can rely on, but perhaps good enough for ham purposes. Okay, Jerry? So I asked the AI to show me what I might do for putting ground rods in the ground. And it came back with, well, down about 1.5 feet, dig some trenches and lay in. First, I did the copper pipe, and it came back and went, well, the round pipe thing has a lot of inductance. You might not want to use round pipe. Maybe consider flattening the pipe out. Well, that's a lot of work, flattening out lots of pipe, a lot of hammering or putting it in the vise and flattening it. It seems like a big waste of pipe, good pipe. So I kind of talked myself out of using my pipe, and I'll do something else with it. But you can buy this 2-inch wide, 10 mil thick strap from ground supply manufacturers for not a whole lot of money, and get like 100-foot coil of it, which is what it was asking when I asked the thing, how many feet of linear feet total are we talking about for a grid like this? And it said, about 100, feet total accumulated length, which isn't that big of a pattern, really, when you think about it. If you're going to do a 10 by 10 area out in your yard, 100 feet goes up pretty quick. So, but then it says, well, I asked it, what about all these? You're saying to avoid 90-degree turns, and you've shown me a grid here with all these 90-degree turns. So go to the next screen there, Jerry. So it comes back and says, well, you're right. A crow's foot pattern would be better. And again, try to keep them, curved out without 90-degree bends as best as possible, or sweeping bends. So I went, oh, okay, well, that's an interesting way to do it. Uh, so then I was like, well, trying to, achieve a 45-degree bend on this stuff, or even a gently curved one is pretty hard to do when it's in that flat orientation. I asked the AI, how about you flip it up on edge, and we put them in on, vertical in there, and then they can peel them off. So go to the next one, Jerry. And it's like, you mean like this? So yeah, flip them up on edge and you can bend them out, weld a bunch of them together, and then kind of like one of these cheap pre-made Christmas trees, you bend the legs out to be your curves. And then it suggested adding a drip irrigation hose line in addition to the bentonite and sand mix to improve conductivity, but add some drip line. You got this laser drilled uh, drip irrigation stuff, and give it a squirt every now and then. Just, while you're putting all your stuff in the ground, add a drip line and turn it on every couple of weeks or months. Just add another zone on your irrigation system and just run it, keep the ground moist. And this would be a way to implement a better grounding system. And also to make sure that the ground that you come up out of the ground here to go to your lightning protection system is routed back to your entrance panel and UFER tied together. It then queried me at one point and said, what are you planning on tying the back with? You're going to use more of the same 2-inch strap? And I said, no, I'm going to use a number 6 wire. And it came back and says, yeah, sure, that's a good idea. And that is compliant with NEC and building code, because if you have this ground, you have to have it tied to your main ground to be in code. But then it goes, while you're compliant, it's not very effective. If you get a big hit from lightning, it's not the inductance in your number 6 cable back to your UFER is going to impede the current and allow the lightning ground to rise above the UFER ground, potentially causing some voltage drop that you don't want to have happen. You'd really like the lightning ground and the UFER ground to go up and down with the transient together. So it was really forcing me to say, fine, I'll put 2-inch strap all the way to the UFER. And then it got happy, because it's like having a dialogue with this computer. You ask it questions, it asks you questions back, and I've found that even if you take a tone with it, it stays pleasant all the time. So no, but I found myself saying please and thank you sometimes to it, just in case it might give me a better answer, because it would give me the wrong answer sometime, or something I didn't really want and I wanted it better. And I'd say, no, that's not what I wanted. Or I'd say, let's try that again, but move this over there instead of the graphic. And it would take another crack at it. And some of these graphics took quite a few iterations of back and forth with it, but it's still fascinating to me that it's generating these pictures.
The kilowatts that big.
Oh, who knows? But it was a lot faster than me trying to draw something, with, trying to go in some CAD program and sketch that up. That would be weeks. Okay, Jerry. So the AI created this, how to stay safe during a lightning storm. I figured I'd best leave it in there for the disclaimer purposes. And, during a storm, stay several meters away from your antennas. Don't go out and hug them. Avoid contact with the antennas and masts and cables. And I tell you, when we've had lightning storms, and my wife said, should you go down and unhook the wires? I'm like, I'm not touching. Should have unhooked them before the storm. I'm not touching them now. Yeah. No, once we retired, we canceled our life insurance policies. Don't need them anymore.
Short the ground, together.
Well, I don't think it matters. They recommended following official guidelines wherever you're hearing recommendations from the news or the radio. And
the antennas are DC ground.
right, we'll get to that too. And then learn from past incidents that you might have had with your any lightning problems you might have experienced before. Okay. Yep. And then it gave me a list of codes and standards. I got to be honest, I did not go look up IEEE standard 142 or NEC 810 or IEC 6235, 3305. Maybe I'll do that one day. So that's why I have the AI disclaimer in there in case there's any egregious errors, because I have not checked all of the things that it's recommended. Okay. Okay. So a little good news, Rob, you just mentioned this. Many antennas are DC grounded, if not most these days, especially commercial antennas. Some basic examples are your folded dipoles that you see people quite often on repeaters. Everybody's J poles seem to be the most popular ham VHF antenna. Hairpin or beta match or gamma matched monopoles or Yagis, loop antennas, many Ballon fed wire antennas. The Ballon, I checked my Ballon design. I use a Guanella 4-to-1 with a common mode Ballon or choke after it, and check to see if it's DC grounded. And in fact, it ends up tying both of the elements together by they're grounded. And all the VHF, UHF Diamond series, their Diamond X's, the Comets, the old Cushcraft Ringo Rangers, which I'm actually helping a person put one up in Elfin Forest right now. They're all DC ground designs. And the beauty of a DC ground antenna is by its nature, if it's properly grounded, won't accumulate a static charge. And without the static charge, it's unlikely to be having a stringer, one of these leaders that comes up off the ground to meet the downstrike. So it reduces your chance of having a lightning strike due to that stick in the sky. One of the questions I asked was in my digging is does an antenna or an antenna tower on your property necessarily make you more of a target of a lightning strike than any other place in your vicinity? And the answer was no, not at all, especially if it's well grounded, because it won't have an opportunity to have collected a charge. There's plenty of things that are high resistance, and as the wind's blowing by, especially on these dry winds and you get the dry lightning, that where the lightning, the winds like Santa Ana winds will cause static to accumulate. And especially in the winter storms when we have the low humidity. So, but no, it does not make any difference. Now, if you're the highest house on a hill and you put up 100-foot tower, yeah, you're going to be the highest thing around, and you're still probably going to be more of a target. It's more of a when more than an if. Sooner or later, you're going to get hit. So, Rob, you're kind of on a hill. Is your tower the highest of anything around?
No, there's stuff around me.
Yeah, higher
We
stuff.
Had a lightning strike about 3 years ago of a power pole
Yeah,
that was
nearby.
just like across the street from me.
Okay. Yeah. So, it's not a magnet for lightning, which made my wife feel a lot better when I told her that. So, yeah. The other thing to consider is a DC grounded antenna is just that. It's a DC grounded antenna. You got to realize that little quarter wave stub or that gamma match or that hairpin match, that's 50-ish ohms at frequency. When you're at the operating, say it's a 20-meter antenna, that stub is not zero resistance DC. At 20 meters, 14 megahertz, it's 50 ohms. So it's elevated the antenna above ground. So in the event you happen to get a strike, on that particular antenna, well, it's not going to be a 50 ohm or a DC. The transient's going to be a microsecond. So that's a megahertz. It'd be roughly whatever the resistance difference, impedance difference of the hairpin match versus the tuning frequency versus the 1 megahertz or so strike transient. So it's just something to consider. Certainly, it becomes more and more relevant the lower in frequency you get. You get down closer and closer. So what? Oh, QRM. Okay. Anyway, it's just food for thought. If you got a 2 meter antenna, 140 megahertz antenna, and it's 50 ohms at 140 megahertz, it's still going to be 0 ohms at 1 megahertz. So, okay. So surge protectors, lightning arresters, their whole purpose is to try and clamp those high voltage surges and route any currents safely to some place to ground. The common devices are gas discharge tubes. Virtually every lightning protector in the world has one, different voltage ratings. It was suggested by one of the AIs that metal oxide varistors, MOVs, or transient voltage suppressors would be playing a part. I immediately questioned that and said, I don't think so, but really? And you'll see in a second, not so much. Basically, how you choose these things is by response time, current capacity, the voltage necessary for your operation. But having a device can reduce your transients by up to 90%. Okay. TVSs and MOVs, not so much on your antenna cables. They have way too much capacitance. Putting one across your transmitter or receive lines would be like throwing 500 to 3,000 picofarads across it and destroy the radio's performance. It's just going to look like a dead short and not do anything. So they're not appropriate. Where you use these and what they look like are these little blue discs that are inside a typical transient suppressor that you use on like a rotor control or other kind of control device. Quite often you see them on communications lines. We used to use them at work on RS-422 lines and RS-485 lines to reduce surges. Okay. The classic antenna surge protector that everybody sees always have a GDT, gas discharge tube, inside of them. Sometimes they're replaceable. You can see on that little Alpha Delta TT3G guide, the little brass knob, you unscrew that and you can dump out your little pellet that's a gas discharge tube and put in a fresh one if it's been hit by a few transients. They don't necessarily go bad from one hit. Some of them have absorbed numerous hits that were just small transients due to nearby strikes. The typical voltage on these things, when you look them up on Amazon or various places, they tend to be rated at 90 volts, which is okay for about a 75 watt transmission, or 350 volts, which is okay generally for a 1 kilowatt transmitter. Most of these particular ones that are shown here are your most generic of surge protectors. They are all DC pass-through devices, which is to say there's just a solid chunk of copper going through an aluminum box with a gas tube discharge tube strapped from the center to the case. And then they give you a little ground stub to hook up to your ground, or give you a way to bolt it to ground. I just got a box of 4 of these Transi taps from a guy in Walnut Creek who had them up on QTH, of all places, I think. And I said, he wanted $35 for them. And I said, okay, well, you ship them to Escondido, and well, how can I pay you? And he said, oh, you're a ham. I'll ship them to you for free. So that was pretty cool. I tried to talk to him. I said, well, you just let me pay the shipping. And he's like, no, you're a ham. I'll send them down to you. And he did. They showed up a couple of days later. And but that's when I was getting started on trying to understand how these things work and are they appropriate and what power are they rated for and what's inside of it. And they claim in the literature that the GDT can be replaced. Nope. The ones I got when I tried to open up on that little uh, far right one there, it's got the little polyethylene threaded stub that has that carries the GDT. It's solidly glued in there, and I finally drilled out all the screws on the back of the box just to see what was inside, and because all the screws broke off, how old it was, they were rusted in there. And sure enough, everything's been potted full in that box, and there is no way to get that GDT out of there. So the literature was wrong. Right.
Seems to be very much undersized.
Very much so. Well, you see, they got this little wispy crimp lug on there, and everything's saying, "Oh no, you really got to bolt it straight to your plate." And the Alpha Delta gives you the big bolt, and they expect you to bolt that to a solid copper plate in a box with a 2-inch flat strap coming out to your ground to make it really and truly effective. You run thin wire, you got this massive inductor you're creating. So, yep, exactly. Nevertheless, you can find some of these lightning protectors fairly affordably, online. There's a lot on Amazon that are less than $20. And, really all they are is a chunk of aluminum with this little pellet of a gas discharge tube inside. So none of them really are, and nothing's going to stop a direct hit. You got to kind of come to grips with that. In the event of a direct hit, your only real hope is that everything is incredibly well grounded. But anyway, some semblance of protection can be had for not a whole lot of money to at least drain off any accumulated static charges or nearby strikes. You can give yourself some kind of protection. Okay. There are some specialty ones. I thought this one was particularly cute from Alpha Delta that I spotted in the DX Engineering catalog that comes. It just basically is a GDT in a little block that you screw onto a UHFT connector and then ground the stud on the bottom. And you can buy those for about $20 if you supply your own T. And ladder lines, haven't been left out either. Basically, they've got a pair of GDTs tied together and fed down to a ground post.
That number 8 wire.
Yeah, through that number 8 wire. Yeah, which is wholly insufficient. Yep. Okay. Just for kicks, I asked the AI to simulate for me a typical ham radio 100-watt to kilowatt DX antenna installation, which I said would consist of a 50-foot line, some sort of DC grounded antenna, a 50-foot cable of RG8U, a gas discharge tube surge protector, and transitioning from that to a 20-foot chunk of RG58 to your transceiver with a 50 ohm impedance. And it built this graphic. My question for it really was considering, because since it's always harping on the inductance of the cable. Well, there's also capacitance in the cable when it's long enough and tied to ground. So what's the overall look of this transient as it hits your antenna, traverses down a coax that has a certain amount of capacitance, a certain amount of inductance, hits the transient suppressor, and then goes back into more coax, which again has more inductance and more capacitance, into a 50 ohm load at the radio. And assuming this 1 microsecond-ish pulse coming in, getting clamped by the gas discharge tube at 350 volts or so, which when it's not like a Zener diode that clamps and just holds you down to 350. When these gas discharge tubes fire, the plasma ball that forms up inside them takes them down to damn near 0 ohms. And so it's not just clamping it to 350, it triggers at 350 and clamps it to ground until it either dies because it's been vaporized because there's so much current, or the transient ends and the voltage decreases and it stops conducting. So nominally it goes pretty much to 0 volts. So, but there is a period of time while it's activating during the transient itself. And so basically it came up with, okay, you're going to have your 350 volt surge, hits on the input side to that gas discharge tube, which is kind of hard to call an input. It's just a place in space where the cable hits it, drags it to ground, and keeps going out to the radio. Yes, sir. Right.
Do you have to worry about any products like the rotator?
Of course. Of course. Oh, of course. Yeah. Yeah. Everything that's coming off that tower. Yeah. And so you use special lightning protectors just for those devices. Yeah. But what I was encouraged by with this analysis, and this is an AI analysis, it may not be entirely accurate and probably should be studied more. But what was kind of cool was you look at the transient at 350 entering this when it hits the gas discharge tube, but then it's got this 20-foot piece of RG58 and its inductance and capacitance and 50 ohm termination. The net product at the receiver, which they show as like an oscilloscope there on the right, is maybe only 30 volts. So now I don't know if you want to hang your hat on that and say, I'm good to go, but it's encouraging that there could be dynamics that should be studied in order to understand whether a simple gas discharge tube lightning surge protector is adequate for your situation. It may be. It may not be. It may be that you just put a grounding switch into your receiver and at least you're not going to have 350 volts hit it. Okay, next one. So the other problem with gas discharge tube and transmission voltages, as your transmitter power increases, the transmission line voltages go up pretty fast. It's your RMS formula, power times square root of power times resistance. And so you've got your 1,000 watts, say, times 50 ohms, and you're going to be at 223 volts. Now that's RMS. Peak is going to be 1.414 times that, so about 316 volts for a kilowatt. 50 watts, you're looking at about 71 volts that gets generated. So these 90 volt gas discharge tube protectors that you see on Amazon or whatever, they're really only good for 50 watts. And that's what's funny when they sell these things, when they advertise them, they don't advertise them by their voltage necessarily. They advertise them by the power they can allegedly handle. When I took apart one of the the one I got for free, I found that it had 350 ohm or 350 volt gas discharge tubes. So the other thing that comes to play is these calculations assume 1-to-1 SWR. You got a badly matched antenna, it may not be 1-to-1. So you may be looking at much higher voltages that can occur when you're transmitting. So you've got to size these guys so that they're not triggering while you're transmitting. And there's where you got, okay, I put a 1,000 watt rated module. It's got a 350 volt gas discharge tube, and I'm going to get a lightning hit, and I'm going to be seeing 350 volts, up to 350 volts hit my radio. Well, is that really adequate protection? But again, as looking at it further, what happens when the transient propagates through that thing? Does it really manifest as 350 volts at the radio when you've got more cable to transit through and its impedance characteristics? So the bottom line is be aware and beware that how these things get used.
Much insertion loss is
Typically 1 to 1.1 kind of stuff.
dB.
Yeah. Yeah. 0.1 dB. They usually claim 1.1 SWR or less and 0.1 dB. That's for HF. Depending on what you're buying for VHF, UHF, it's different. Okay. Other lightning protectors out there, some of the higher end models, the polyphasers and the Morgan systems, which used to be called ICE. I like the Morgan Systems products. They're nice. They're actually reasonably priced at $60, which is about half of the polyphaser, and they've got some extra components in them. They've got inductor to a DC shunting inductor to ground, which at HF frequencies it just disappears because of its inductive reactance. And they've got a blocking capacitor, which again at ham frequencies disappears due to its low X of C in capacitor reactance. You can get DC pass-through models of these things. All of the other that are just classic, just GDTs are all DC pass-through devices. The polyphasers and the Morgans, unless you're asking for DC pass-throughs, they're generally DC blocked devices. Okay. The difference being, you look here at the alpha delta schematically, it's an antenna connector on either side and a gas discharge tube. The Morgan Systems has got a resistor, not sure what value, a blocking capacitor, a gas discharge tube, and an inductor to ground. Polyphaser just has the capacitor, no inductor. Okay. So there's a bit of a conundrum when you start talking about this inductor and capacitor, because my first thought was, damn, that's cool. There's an inductor to ground, which will drain off any static charge. And there's a capacitor that any static charge that happens to be on the antenna isn't going to get to the radio. And anything that's high enough voltage, the gas discharge tube is going to kill it. Great. Well, that's wonderful from the static discharge world. A transient and these inductors and capacitors, a whole nother world. That transient comes down, it sees that inductor, and the inductor says, I'm out of here. Its X of L is going to go to the moon and just disappear out of the circuit. And the capacitor is going to look like a dead short to that transient. It's going to go straight on through to the radio. So you're right back where you started, with just the gas discharge tube taking on the job to keeping things safe. So it's, I don't know that they're pointless add-ons. I mean, they make you feel good, and they're nice things to have in the circuit, can't hurt, but are they really doing anything for you in the world of a transient? I don't think so. It's a pulse. It's a pulse. It's depends on the frequency characteristics of the pulse, but in this, microsecond kind of, so because these things need to be invisible to your HF frequencies, right? The inductor has to look like an infinite resistor to the HF frequency that you're pushing in parallel with it. And the capacitor wants to look like a zero resistance to the HF that you're shoving through it. So it kind of made me start thinking, well, what's the point of them? Okay. So again, ask the AI to do a simulation for me and just confirm all this. And it kind of did. I messed with this, but I argued with the AI quite a bit over this one today. It's probably I did. I had to put my foot down. And it took a tone with me at the end because I blocked it out on the screen. But at the top, the graphic it gave me was very glitzy, kind of like that thing in the middle with the cylindrical capacitor and cylindrical uh, 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 stuff. It was very pretty, but it didn't represent the circuit I was trying to analyze. And I had given it the circuit at the top and asked it to analyze the C and the gas discharge and the inductor, and literally pasted that picture into it that came off of I think the Morgans, one of their tech papers. Just copied it and pasted it and sent the picture to the AI and said, analyze this dynamically from a transient response perspective. And it came back at the end and had all the math was basically right and stuff. And I kept forcing it. I finally said, I want to see an exact picture of this circuit. And the title at the top said, exact picture of their circuit, revised per your request at the end. So I had to put my foot down with it. But it's a pretty picture. It's a little hard to read, but it basically says the same thing at the end, that the capacitor and the inductor fall out of the circuit in a transient scenario. Okay. So what about just disconnecting those antenna cables? Walk up to the back of your radio, unhook you hear you're going to have a thunderstorm, go unhook them. There was a quote from somebody, expert lightning safety advisory, that disconnecting them is the simplest and most effective way. It's a great thought, but disconnecting the cables inside your house it has its own dangers. Now you've got hoses from your tower bringing in lightning that is going to go to something. If you get a big enough hit, it's traveled thousands of feet through the sky, and another foot or two inside your house to get into a wall and into your ground or into your power or onto some other piece of gear on your bench is not a big stretch of to believe. So beware. Unhooking them inside is maybe not something you want to do. Okay. So I saw this other device in my digging around. Never heard of it before. It's called a Paradan. Some guy named Dan. I think he's in Florida, and he's got a little business. So can you click on that, Jerry? Will it play? When you click on the graphic, just click anywhere in the middle. It played on my machine. No? Are you clicking in the middle? No. Go back. Okay. Well, you're screen sharing. Can you right click on it?
Well, you can just stay out of it. Yeah.
Is there a play? Huh. That's a video, and it played perfectly. Is this a brand new version of LibreOffice you're running, or is it years old? Okay. I'm guessing it must be an old version or something, because it plays fine on my computer with Libre. You're running LibreOffice, right? Okay. And you're running the slideshow, right? Okay. Well, that's a bummer. Slideshow. Play from this slide. Click on that. Click play from this slide. Start from current slide. Down one. That one. No Playsies video. Okay, well, that's a real bummer. Okay, next page. I thought this might happen, so I prepared. Next page. So the guts of this device has a pair of Omron G2R-212 relays. Took a lot of digging on that video and zooming in and spinning it all around over and over and over again. And what it does, they call it a Paradan antenna disconnect actuator. It's really a relay, a pair of relays. What it does is when you apply power, it actually connects everything together. In a power fail situation, everything turns off and it shorts out the antenna coming from the antenna, ties the center and the middle conductor together, Rob, like you were asking, and it grounds them to earth stud case. It also separates the antenna, the outside antenna, from the indoor antenna or the indoor receiver radio, and it takes the radio connections and it shorts them, the center pin and the shield together. And if you look on the other end of if you look at the far end of that box, you'll see that the radio side SO239 connector is isolated from the box. So it actually lifts the radio shield and the radio center conductor coax off of the box ground so that the box can float up and down with the lightning and go to ground, but not take that signal all the way through to the radio. That ends the antenna end. As you can see on the antenna side, it's got a gas discharge tube there to take care of any big transient that might hit the relay. I looked the relays up to see, because my immediate thought was, well, your good sized surge is going to go jump right across those relay contacts, are only a millimeter or so apart when the relays flipped over. But the relays claim that they've got 5,000 volts of insulation or isolation from terminal to terminal. And maybe that's why the guy picked that relay. I don't know. One person commented in some comment that I read online was that there's no apparent isolation from the relay coils to the power supply, that again, in some kind of significant surge, maybe you get a surge from the antenna wires that couples over to the antenna coil connections. And so what I was saying, my belief is you probably need to implement a GDT or transient voltage suppressor or MOV across the power signal, the power line going to this thing as well. But all in all, it's a nice build, and it's, I think, reasonably priced at $130. And apparently the guy sells these things like crazy in Florida, lightning capital of the USA, and people rave about them as protecting their systems. So from a not terribly expensive perspective, this might actually be a fairly good solution for, that's a step above your basic lightning protector. Especially mount this in a metal box outside your house so that anything that's going to blow up is going to blow up in that box, not in the house. And then bring in a more usable, instead of bringing that LMR 400 all the way to the radio, stop it at the box and bring in an LMR 240 to the radio. So I kind of like these things. And I like the fact that they're not egregiously expensive. So it's also something I could make myself because it's not hard to build that. It's an easy circuit board to design. So not sure if I'll get that carried away. Yeah. Okay. So then I stumbled upon this guy, and it's a damn shame the video won't play. This is a very clever design that a guy took a linear actuator, which you can buy these things on Amazon for $50, and they'll go about a foot or two. Built-in limit switches, everything. You just give it power, off it goes. Reverse the power, back it comes. And Uh, he basically took a handful of coax connectors and bolted them to a piece of angle bracket. And he even used a couple of DB9 connectors for his rotor. And as they come together, it just stabs the uh, the PL259 and SO239 together with, and it's commonly available. There's PL259s that are push on adapters. So you don't have to unscrew it. You can just shove it on. They're like $9 for two of them. So it's an easily built adapter. To me, mounting this thing to wood
Didn't say until the wood works.
indoors, and you get a lightning strike and it decides it's already come thousands of feet through the air, it's going to want to jump to that other chunk of metal on the other side, which has got, both of them have got ground. Have you really saved yourself here, or are you creating a problem? But I think there's designs that could be implemented to improve that. Say once it's retracted, it folds up a piece of metal in front of each of these to intercept any strike that might try to jump out of a cable and go to the other side, and routes it safely to ground.
Like to come to that plate rewired.
Yeah. But it's still, if it gets there, it could make it to the radio. So anyway, it's cute. I think it's really cool. The video's neat. But it's one of these belt and suspenders things. And I still think you would want to have some kind of transient suppression outside the premises to absorb any real shocks that might try to come in. Okay. All right. So this came actually off of the AI presentation that Microsoft made for me, Microsoft Copilot. But it was all good suggestions that, on a regular basis that you go out and inspect all your antenna connections. Occasionally check your ground resistance as if test I thought this was cute. Verify your surge protection devices and arresters operate correctly. Good luck with that. You're going to go find yourself a nice surge and subject them to prove that they actually triggered. Log all your results as if, and fix broken things and review your schedules. Nice. It's all wishful thinking. I'm not sure how many people are that rigorous. Okay. Conclusions I came up with. We live in San Diego. Can we safely pretend that lightning's not a problem? We all do, or many of us do. I've been doing it for 15 years. But realistically, it's probably begging for problems. And something should be at least done to ensure you've got good grounding practices, and spend a little money and put in some kind of, minimal surge protection would be, not money badly spent. And then considering the dynamic response of that one analysis, perhaps a basic gas discharge tube really is suitable and sufficient to protect your system. Which of these protection mechanisms is best? Is the gas discharge only good enough? Do you need the enhanced stuff with inductors or an outright disconnection system? Again, that's sort of what's your risk tolerance. I really kind of think I'm going to end up going with the Paradan and buy a couple of those, and that'll protect 4 antennas for me. The Paradan, I will say, is only applicable to HF. It will not work up to 6 meters. That's it. You're done. You're not going to put it on any of your VHF, UHF antennas. It claims a 0.1 dB insertion loss and 1.1 SWR, but that's for HF frequencies. You can see just by its design, you wouldn't want to shove VHF, UHF through that thing. So you would shove 12 volts out to it. No, no. Say, well, normally it might be living right outside your house, you know, in a box of some, bring all your cables to that box, and then they come into the house and you put that in the box. And then you just got to bring 12 volts out to it from your shack. Yeah, there's a pair of wires on it to hook 12 volts to. You might, yeah, yeah. And you could rewire it to feed it with the bias T. Of course, you got to build the bias T material for the receive side, or for the inside the box there. Yep. Matter of fact, I do a similar thing on my house, up in the trees. I've got a balun, and I've got a pair of dipoles, OCF dipoles that come off of that tree. One is for my 80 meters through 6 meter dipole, OCF dipole. The other is for a 30 meter, 17 meter dipole that I can flip a switch in the shack and it shoves 12 volts down the line, triggers a relay up in the tree, which just switches over to the other pair of wires through a bias T network. Okay. Lastly, I just got a list of all the various vendors that I found online that I looked at their websites and digging all this up. I'd never really been to the Georgia Copper or Harger Lightning and Grounding. Boy, do they got a lot of cool stuff for grounding. I was pretty fascinated that these guys cater to the radio grounding world. So I figured people that read this might want to know where all this stuff was available. Virtually all the manufacturers, Polyphasers, Morgan, Alpha, Delta, Paradigm, you can get all their stuff at DX Engineering, HRO, and other places. And you can get all the cheap lightning protection in the world on Amazon. So I like the Mayday grounding guys also had some interesting things. All right, that's it, I think. Yep, the end. Questions from the.
I had two questions. So we're at the help from you. With a 50-foot self-supporting tower and a rotatable log periodic. Yeah, Daytron. And anyway, the lightning hit the tower in the one afternoon. The lightning protection protected the radio and everything like that. But somehow that lightning bolt got into the old Ethernet, what do you call it? The old stuff with coax. Yeah, anyway, it blew every single interface to every device you had online. So, but that's what I have to help from you. And yeah, that's why I mentioned that. Yeah. And then the other thing was when we were installing repeaters, VHF repeaters in Africa, the installer always put a couple of loops of coax right near the antenna because supposedly the inductance of that loop would hold back at least part of the lightning.
And then when it moves to light,
Where you had your copper grid and then went to flat copper, how would copper flat braided wire work?
Burying it, and it got very upset at the idea of burying copper. Corrosion reasons. So basically, it was like you can, if you put copper braid in, it's going to just disintegrate. Yeah, if you put copper braid straight in the ground, it was not going to last long. It would just basically disintegrate. Why, I don't know exactly, but it was just saying if you put copper plate in the ground, copper strap, it would not have a problem. Even one of the things I was trying, because I was seeing if I could get cheaper on all this, and because a lot like copper or ground rods, if you go to Home Depot and buy a ground rod, it's copper plated steel. Yep. And you grind and then you clamp to it, and it's done that way because it's going to absorb a transient and it's going to ride on a skin effect. and it's also code. So, and it's cheap. I mean, those ground rods are $20 for an 8-foot ground rod. So if you can drive it down, thankfully they make jackhammer attachments that will let you send it straight down until you hit a big enough rock. And in Escondido, it's about 2 feet in.
Big ditches for that.
I haven't done anything
Oh,
yet.
I haven't done
I'm
it.
still in the research and design phase. And yeah, I'll probably ask the gardener to do it when the time comes.
Get $1,000 bill.
Yeah, no doubt. Anything else? More questions?
Comment.
Yeah.
Ask one online.
Yeah, let me get my comment, then I'll let Bud go back online. So Gail and Jim, Joan and I used to go to Cayman Islands, and one time we were down there, and they get a lot of lightning down there in the Caribbean, so their station is really well grounded and all that, but I don't know how close it hit, but it was one of those flash booms, it was like almost instantly sound and lightning. And all the power went out for about 2 seconds. The whole station shut down. The laptop didn't because it was running on batteries, but everything else shut down. Everything came back up except what was it? You had a wind keyer on it that broke, or the radio interface stopped working. So then we had to make sure that anytime we changed frequencies, we enter that into the logging program that we moved. So that blew up, and also the drive for the big antenna that luckily was pointed toward Europe at the time, so it didn't move anymore. But that thing is, then I guess they had problems with it blowing all the time. But so everything went off, and I'm down under the bench. I'm looking, why is nothing working? And then like I said, the lights came back on, and then took about a minute for the station to come back on the radio, and then everything's working. So I put the headphones back on, got it back on the air, and I guess Andrew, the guy that owns the station there, or it's on his land anyway, he came out, he opened the door, looked and see if I was okay. I was, headphones on, working away. So he said, okay, he's fine, and went back inside. But you had a little problem. Did you have a problem with CW with it, something? Or it was just the radio interface. Anyway, no, I didn't feel anything. It's just like a big, the windows in the shack are pretty small because it's a brick building with little windows. And I just saw this flash and then an instant boom, and the whole place shook, right? It was real close. But it was an interesting experience. Back to the online.
Yeah, my only experience with hair standing up on my arms was once on a sailboat in Western Australia, Fremantle, and all of our displays on the boat started flickering. We had about 20 displays around us, so America's Cup boat, and all the displays started flickering about 10 minutes before the race was supposed to start. And people said, "Oh, look, the rigging is all glowing blue." It was St. Elmo's fire. And thankfully it sort of dissipated and all the instruments came back to life like nothing had happened. And my job was keeping all the instruments running, so I was kind of in a state of panic. What? Yes, there's an online question. Yep, online question.
Is it my turn?
Yep, go for it, Steve.
Okay, thanks. Great presentation, by the way. Learned a lot there. I was especially interested in your discussion of how a grounded metal tower next to the house is not necessarily attracting the lightning because it's dissipating charge and it's electrically neutral, whereas a nearby trees probably get a charge. If I got that right, I'm thinking about, is that what the purpose of lightning rods are in office buildings and things like that, is just to dissipate charge so the building is electrically neutral? Is that how those work?
I really don't know. I've always seen those lightning arresters on buildings and old barns, especially back east. But how they work, and you always see the ground wires for them spaced off of the building or off of the roof on little standoffs, and going down to some ground rod in the ground.
So I'm
yes, and they're always very pointy. They're always very pointy.
Right, so I'm assuming that couldn't handle the direct bolt of lightning. It'd just be wiped out. But I'm thinking if it's dissipating charge up there, maybe that's the purpose of it,
It
just to
could
not
be.
attract the shot. Mhm.
What, Bob?
Going back years ago, there was a company, maybe they're still there. It's offering pointy things to go on towers, and they claim that there's a zone of protection.
Yeah, they call it a cone of protection which kept getting referred to in these design things.
Yeah.
When I was asking the AI, it would refer to a cone of protection. Yeah. So yeah, I don't really know it'd be interesting. Ask the AI. It's a great, all these questions. It's really kind of fun asking the AI, go into Google, Gemini.google, and it'll say, what do you want to ask me? And you can basically strike up a conversation. And it's very interesting, the breadth of its knowledge. Now you got to go cross check some of the answers because it does come back with some BS sometimes. Anybody else?
Yeah, I mean, I've had experience with lightning when I was living in Valley Center. I got hit and it didn't hit the antennas, didn't hit the radio. It came through the telephone line, wiped out everything. Took a 2-meter radio, one side of it, 2-meter 440. It's an old Yaesu radio. And that was about, say, 40 years ago. And I still remember. And that's back in the day when you replaced a board, it wasn't $100, $50, it was $200 a board. I had to replace 3 boards in the computer. I think it was an old 386. That was a past experience. Here I disconnect. I even think there's a thunderstorm, and plus I have on my phone called lightning. And if it gets close, I've already disconnected it. It's 30 miles away, I'm disconnected. I don't mess around here where I'm living now in Cottonwood. So that's my story. I'm sticking to it. Go ahead, whoever's next.
Steve Handrop, K6RSH. I grew up in Florida, and I've almost been hit by lightning more than once. And he was just talking about hair standing up on your arm. Yeah, that happened to me. I was out in a poncho, soaking wet as a Boy Scout, and I stopped to see what red ants had got on me. No, the hair on my arm was sticking straight up. If I hadn't have stopped walking, the tree that was like from here to him got hit by lightning. I couldn't hear for like 30 or 40 minutes, and it was like dynamite went off next to me. But the problem was I wanted to tell you about we learned to disconnect our appliances, whether it's a TV or whatever. We had one deep freeze that got hit not once but 3 times. Our neighbor's houses got hit. I got to see lightning hit the TV antenna on a 40-foot pole, went into the house, caught the house on fire. My other neighbor, the lightning came in through the phone line, went across him in front of him sitting at a kitchen table, hit the washing machine or whatever, and went through the corner of the house and hit the septic tank outside. And so that was kind of like, oh my gosh, how lucky we've been. I got on the power company, said, you need to check our power pole to see if it's grounded properly. It was not grounded properly. They put it in the ground after I started complaining on the phone. Anyway, moving on, being on the East Coast, I saw a lot of lightning. I worked with the Navy on the command centers and stuff, so forth for the Navy, both portable and fixed. And so one of the things I found out, like our command center in Jacksonville, Florida, they were having a dry spell. And I was working with the Joint Command, which grades us. And 2 of the things I learned is we had to have a 3-point ground. And if it wasn't below 2 ohms, it failed. So we had to go down. We had 1 ground rod. We had to put down 33 feet to get the connection that before they would pass us. So I also worked talking about disconnecting cables I was into radios from the time I was 8 years old on. I learned to disconnect it, in the house. If it was really bad, I'd throw it out the window. And so one of the problems I saw with the not disconnecting stuff, at one time I had a facility mobile that was in Little Creek, and we were having some hellacious thunderstorms. And it was so bad, I told my people to disconnect all the power lines before the storm came up, all the antennas, just coil them up, leave them outside. and we went into a building. I saw the lightning hit our 42-foot HF whip. And luckily, it didn't destroy any of the equipment in the tents we had there. Really, Murphy's Law missed us there. One of the other things I had in Bahrain, which is nothing but sand. And how did we get aground there? It's called air conditioning water. The air conditioning water, we ran right with a pipe right down on top of the ground rod and just let it soak the ground forever. And that's how we got aground there. So for you guys that going out on the desert playing and well, we get great reception on the desert because we don't have background noise from the city. Well, if you got your air conditioner running on your RV or whatever, have it drip on your ground line so you get a good line there. And I've got a lot of experiences, but I'm not going to bore you with them. Anybody else? Nobody else.
I have a question.
Sure, go ahead.
Yeah, that paradigm assembly, I would suspect that the circuit board in that box won't last 1 microsecond. But the other thing is the reason mobile whips have a button on the end is because it reduces the field strength on the antenna for outside influence. So that's why on buildings the lightning arresters are pointed, very, very sharp point that creates a super high field. And then that allows you to drain off the static charge. And I think that's more likely what they're for than stopping a major hit. Because, a 4-gauge wire and a piece of wire sticking up with a sharp point on it isn't going to handle a whole lot of current. So I think that's what it is. You if you can bleed off the charge, that's why a lot of the matchboxes on antennas have an inductor somewhere in there that is high impedance for the HF, but DC wise, it can bleed off the charge.
Bleed off the static, right?
Right. So that's the biggest thing. But yeah, for me, I just disconnect. But I also have one of those polyphase things out at the antenna. I haven't checked it recently, but you know what? I have a ground rod right at the base of the antenna, and but it's about 1/2-inch aluminum, and so it would probably disintegrate if it was a direct hit. So you're just kind of out of luck with that. But for bleeding stuff off and things like that, it would work pretty well. One other thing you might want to remember is that putting ground rods in different places isn't necessarily good, because there was this condition one time where this guy had a diesel electric set. Was using the power to run tools and things for construction. And the house he was working on had a ground rod, of course, and so did the diesel electric set. But they took a hit, and the hit went right into the ground and right over to the house ground rod, and blew out shit in the house.
Yeah, that's why you have to have the two grounds physically tied together electrically by code. If you have more than one ground rod, you have to tie them together.
Right.
Per code.
And you don't ever want to have any kind of connection that isn't a bolt, because it's just not going to last. I mean, even if you weld things together, that's probably okay because it's actual metal. But any other method is it's not going to work very well. I mean, it's the same thing you run into. I ran into this earlier where if you're running a lot of batteries with solar and stuff like that, and you have large gauge wire, you never want to solder anything. You need a gas tight crimp. So that means when if you have heavy current, like 300 or 400 amps going through this wire, it's going to melt any solder you're ever going to have.
Right. Yeah, any high temperature connection can't be soldered.
Yeah, just like in your car, none of those are ever soldered. They're crimped. But anyway, that's all I wanted to say. Thanks for doing it, Bud. That was a good presentation.
Okay, Rob.
Great. Well, thanks. We'll do a quick roundtable here. It's getting late. I have a couple of items that I wanted to talk about. First off is elections are in June. So if anybody is interested in any of the positions, president, vice president, secretary, treasurer, we've separated, and the three board members, throw your name in the hat by next May, next month's meeting, and then we'll have the election we'll publish the ballot, and then we'll have the election in June. If not, the standing board, if everybody's interested, will stay on. But if anybody has a burning desire for leadership, come forward. The next item is we were talking about Field Day as a club entity. And at the board level, everybody seems to be committed to another club or out of town or whatever. But is there any interest in operating Field Day as a club? And we thought that we would tie into the the Poway Club at Lake Poway. Is there any interest in Field Day for a club? Yeah.
This year we're going to be up the hill on Beaver Street Parkway at Commercial Park.
Okay.
Better location. Good Hollow Pepper. At Coles, if you know where Coles is up there. Big parking lot. It's going to be tight. You know, the station will be close together, but it's higher and less. It's west of that. Okay, block. Yeah. So you went in and out further and Coles.
So is anybody or everybody or anybody interested in operating Field Day as a DX club?
Hey, Rob, I got a comment.
Yeah, go ahead.
Anybody that's operating Field Day, even if they're operating from home, as long as they're related to a club, they can process their score so it gets added into the club rather than just your own. So you can operate Field Day indirectly and still support the club.
Yeah, the club's got a stage.
No, it can be a team.
But does the club have to register as a club would still have to register as Field Day station?
And the third item is this Saturday is the ears auction out in the parking lot, which is usually pretty good with good information, good equipment. I don't know that much about the details, but I'm going to turn it over to Bud, and then we'll kick off the roundtable.
Okay, yeah, I'll be at the auction. I know that, and I've seen the preliminary pile of stuff. They Ears gets a lot of SK estate gear over the course of the year, and they've got quite a collection of gear this year that will be at the auction. I saw the room where it's all stored. It's at Dirk Reschle's CPA office where we have the auction, but it's a good one. It's Saturday morning around 9 a.m. Yeah, got an auctioneer. Yep. And basically what you do is you show up around 8:30, 9 o'clock, and you got time to sort of peruse all the tables full of gear. It's I'd have to look it up. Dirk Reschle. It's 4th Avenue, Escondido at 4th and Calmia. And it's Dirk Reschle CPA. I can look it up here. Give me a sec. Here, hold that line. Okay.
Everybody stand by.
Go to yours.
I have to admit, some of those AI generated pictures look like cartoons out of Mad Magazine.
You can go to earsclub.org. It's on the website.
The address is 230 East 4th Avenue, Escondido. And it runs roughly from 9 a.m. till probably close to noon before they get through all the items. And I'm guessing they probably got 100 items ish to auction off. You're also welcome to bring any stuff you want to auction. So if you got stuff that you want to take and sit on a table, it's two ways to do it. One, just show up, put it on a table, sign in with the person running the table, the auction, and I think it works out to be I think it's a $3 per seller registration, $2 registration to sell, and the club commission is $10 or 10% of whatever you sell it for, unless you choose to donate the proceeds from items to the club, in which case there's no fees at all. So a lot of people just show up, lay stuff on the tables, and say it's for the club, is the donation to the club, anything the club gets for it. And I've had that go two different ways. I've had stuff that sold for $1, and great, it's gone. It's out of my garage. I've had other things I put on a table, think it would go for $1 and go for $100 and go, damn, I shouldn't have donated that. So anyway, I'll kick off the roundtable. Bud, AE6BH, nothing to report. I've been doing other stuff this month, and the DX has been stuff I already got.
Can you have the camera follow over here?
Ted, W6TED. As far as field day goes, I do a lot of soda. So what I'm doing is a drive up summit, 4-wheel drive up on Thomas Mountain in Riverside County. I'll take a hex beam up with me and then run a 40-meter dipole as well. And maybe a random wire long one for 80 if I decide to stay up the whole night. But that's my plan. If anybody's interested, always welcome. I'm usually up there alone. Bud came up and joined me a few years back. But it's a good spot to work.
Beautiful.
Yeah, it's a beautiful spot.
Bridge too. You got perfect view to the east, perfect view to the west.
Yep, 7,000 feet.
North.
So,
Really cool.
yeah, it's a good spot to operate, and nothing like having a 7,000-foot tower.
Hi, Jim, K6ZH. So Joan and I and Mike and Gail and Jim and Linda went to Santa Maria along with a couple hundred other people for the DX convention. We had I counted up 14 people from San Diego that were there. I may have missed a couple. I wrote up a little article. I was kind of late in doing it. I sent it to our newsletter editor just this afternoon. So it was a mini Visalia. For me, it was old home week. I graduated from high school in Santa Maria, and I actually got my first novice license 1 block away from that hotel in downtown Santa Maria. So a lot of kind of strange memories there. But anyway, so it's going to be in Visalia next year, but it's going to be in March instead of April. It's going to be back at the Wyndham, which is by the airport on the west side of Visalia. It was so I wrote a little write-up, and anybody else that wants to chime in, it was the only thing that was missing totally was there were no raffle tickets and no prizes, and because there's a lot of overhead to do that stuff, and so I understand why they didn't do it. I know we talked last time about Bouvet and Sable Island. I noticed today that S21WD confirmed my contacts with him on Logbook of the World in the last couple of days, so that was real quick. It didn't cost me anything either, which is nice. So my wife Joan and I are going up to our place in Goldfield, Nevada. We'll be there for seventh area QSO parties the first weekend of May. It's not as big as the California QSO party, but it's pretty good, and it's an opportunity to work a lot of rare counties in all 7th area states, and we're usually the only ones on from Esmeralda County, Nevada, and KG7 Nancy Victor. Bud and 7CW is going to be with us there at the start of the contest, and so we usually do pretty well. It's nice to be on the other end of the pileup once in a while.
Mike and A6MB. Not a whole lot of activity. We just got back from Mexico a couple of weeks ago, so it's illegal or impossible to operate from Mexico. It doesn't stop us, but we don't make too many contacts from down there. Couple of antenna news. Steppers coming back into the ham radio side. They're going to start manufacturing steppers again, and Cushcraft and Highgain were acquired from Martin Jew to continue on after he closed down MFJ. So some antennas continue to go on, some legacy ones. So that's about it.
Gail, K6GO. Hi to everybody out there that is zooming on in. Good to see all of you. And yes, Santa Maria, great time. My only comment about the historic Santa Maria Inn is that it should be called the prehistoric Santa Maria Inn. I love the architecture. It was built in 1917. Oh, but the rooms need help, need a lot of updating. Anyway.
We had a suite for some reason.
Oh, they got the presidential suite. Who did they bribe? Anyway, and I finally uploaded because we were, of course, together in Mexico, and even the Mexicans can't barely operate. So finally uploaded, and I had 2 new ones, which was very exciting. And I meant to write it down to bring here to brag about, but I didn't. So,
But not from Mexico.
No.
Their own context and before.
Yeah, that I never uploaded. So, and Bud, if you get any calls, because a lot of times clubs watch what clubs present, you should combine your presentation with Steve and you give the kind of, the engineering point of view, and he'll tell the common story, true story that happened in Florida and go back and forth. And I think that audience would just love that. So that's my idea. Anyway, passing it on.
Andy, WB6UPW. This is my first time here. I'm happy to be here. From Rob, actually. It was one of the lunches that Tom runs. Anyway, I retired recently, and I'm getting back into my old hobby that I started when I was in high school. I dragged out my old SB 102 that I built, and it still works. I was happy to hear that tube rigs are less susceptible to lightning than solid state. And just getting back into it, putting up some antennas. Anyway, I'm happy to be here. I'm in Carmel Valley, in a suburban jungle. You too. Yeah. So, I'm a little limited, but I'm putting something up above the roof, and I'll see how it works. No HOA. No, at least. Yeah. Yeah. I mean, I've got an end fed right now that starts around maybe 8 feet by the front door, and it goes up to a tree. So I'm going to just raise that up, and that should be better. Anyway.
My name's Tom. It's only my second meeting here, and KNX TXI. I'm on a learning curve. I'm trying to figure out a lot of things. I'm an ex-engineer, and I've got a 4-wheel drive rig out there that I'd like to talk to you about. And I don't have too much to say. I brought a couple of radios in for somebody to help me set them up. They're just a couple of handhelds. 70s, FT70s. And if anybody here can help me before we leave, I'd appreciate that. Yeah.
Well, we have to have the secret vote. All in favor? Any opposed?
Set up 5.
There you go.
Good evening, Danny, WB6FWS. Really not much to report. I've just been recovering from lots of illnesses and a wife that just had open heart surgery. So maybe I'll get back on the air one of these days, hopefully.
Hello, Quinn, KI6LAT. Haven't been doing a whole lot of anything because work and certification courses that I have to get up on and everything else. I have been relearning or reacquainting myself with CW. So I learned that in the Navy 40 years ago, and so I'm getting back into it. So
Good.
Tom and 6JOJ, no hablo dit, but nothing else to report. Jim, November 6th, Victor Hotel, and like they said, we were at we enjoyed Santa Maria, and we had a good room. Now, granted, it was a big room. Granted, some of the furniture was a little worn, but not bad. It was fine. And we enjoyed it. And one nice thing was that there's a ham that we've known for several decades actually, Jim W60UL, who lives not too far from Santa Maria, as a matter of fact. We hadn't seen him for the last few conventions at Visalia, and he happened to be there this year. So we old friends again. So that was very enjoyable.
WA6HGA Linda, and I too was in Santa Maria. And I would like to say kudos to Gail for facilitating the YLRL forum. Did a great job, and it was well attended. Thank you.
Tom, W0NI, no report.
Randy, KQ6RS, haven't been very active on HF for a while. I've been pretty active with amateur ballooning and and there's a Mount Carmel High School amateur radio club that I mentor, having them build all kinds of projects and passing now I'm a VE to test them to get their tech licenses or upgrade to general. So that's what I've been doing for fun.
Michael, KB6T, quick anecdote. Does anybody know about the treads of the Mars rover? The treads of the Mars rover, they originally wanted to imprint the letters JPL on the treads, but NASA said they didn't want to do that. So it's JPL in Morse code.
Jim, K6SMT. I got my power supply replaced, my Samlex power supply. My IC7300 died and it had a 3-year warranty. They sent me a new one. So I'm back on the air.
Well, I'm not going to break mine to get the 5 megahertz range. Anyway, one more lightning story. So when I was about 10 years old, Mom had me in Red Cross swimming, which was in the bayou, which is salt water. And I've been born in Florida. I was in the water all the time from 5 years old on. So one day we're finishing up the Red Cross, and all of a sudden lightning hit a church spire about a mile from us. And I got shocked. So I got out of the water, went straight to the car and got in it. My mom followed me back and said, "Steve, I didn't tell you you had to get out of the water." I said, "Mom, you may have to tell me more than once, but God's only telling me once."
Great. We'll go to the online people. Tom, K7YMG, go ahead.
Yeah, this is Tom, K7YMG. Not much to report, but I have been on the air. The conditions are kind of cruddy right now. The flux is dropping, and there's a lot of weird activity from the sun. But I did work Bangladesh and a couple others. I did work the 3Y in Beauvais, and I actually sent them some money. So maybe one of these days they'll actually give me a confirmation. but who knows? But anyway, that's about it. I'm up to about 250 on the number of countries, so I'm getting closer. But I'll probably die before I get to the Hall of Fame. Anyway, thanks for the meeting.
Thanks for stopping by, Bob, K9RHY.
Hi, Bob, K9RHY. Nothing to report. I enjoyed the presentation on grounding. I wish I had heard that before leaving San Diego and moving to Knoxville, where we had 20 times more lightning activity than you'd ever see in Southern California. Lots of similar stories, so it was like deja vu. I hope that the story I put together for the latest issue of the San Diego DX Club Bulletin with the DXCC accelerator was helpful to some of our members. And I look forward to doing that again next April. That's it.
Thanks very much. I got a chuckle out of it. Ron, N6XT.
Thanks, Rob. Hello, everybody. I worked just for grins today. I have goat heads around here. I know people don't know what those are, but they get in your shoes, and if you do not want to track them in the house, they will stick to your feet like glue, and they hurt. So I was picking those out while I was working FT8, and I happened to call Israel, and they answered. And that's about all I've worked lately, because the Flex has issues with single sideband. So I use the other radio for single sideband. So anyway, what else? So I had a bridge put in. I had to float a car loan for that, having a partial put in my lower mouth, and that's where I float the loan. So not too much else going on here. It's getting warmer. So everybody have a great week coming up. 73. Back to you, Bob. Thanks.
Take care. Thanks. Brian, you're up next.
Thank you. The presentation was very helpful for me here in Texas. Having grown up in San Diego, arrived here in lightning storms, and so I don't have anything up, any antennas up yet, but it certainly had impacted on how I'm going to be designing things and where to disconnect and so forth. So it was very helpful, Bud. Thanks a lot for that. And I don't have anything to report. So back to you.
Great. Well, thanks for stopping by. Ed, long time no see. How are things with you?
Hey, doing well. Thank you. It's at AE6BH back in Missouri. And we get a lot of lightning. Just had a huge storm this last week, but no hits. I do a lot of disconnecting. The other thing I wanted to say was thanks to Bob for the club bulletin. You do a tremendous job. Appreciate that. And say hi to all the guys from down the neck of the woods where I used to live, and they're in near La Mesa, San Diego border. Good to hear you. And the other thing is I want to tell Jim that I did get my renewal in. So thanks for having us here on the online, and appreciate the meeting. Appreciate the presentation. Good to see you all. Take care. 73.
73. Thanks for stopping by. I have two more housekeeping items. One is Gail notified me, and I was going to ask Bob, that this place may be closing down. They sold the shopping center. So does anyone know anything about that? No? Anything about this shopping center having been sold and the restaurant may close? Do you know what the time frame is going to be? No. Okay.
Wait staff who said that center was sold. And you notice that building on the corner was under construction, reconstruction, and
right.
So they know something. We don't know when.
Okay.
But they're the same. It's just month to month now.
Bob LaRose is our contact person for the restaurant, so I'll contact him and find out, and we'll get some more information. And is anyone familiar with the FT70 that can help Tom program? I think, Tom, the best thing is somebody with a laptop. No, it's It's an analog, 2 meter 440. Anybody? Tom, where do you live? Where do you live? Here, Santa. Well, if anybody could help him, why don't you talk to him? I think we're going to let the people online go, and we're going to have our auction for the or our raffle for the booze. 73. Thanks, everybody. See you in May.
Thanks a lot. Good to see you, Danny.
Well, I think of it. I sent an email today, KOASCA, the guy who talked about, our presenter for the presenter for Beauvais, KOASCA. I talked to him at Visalia, and he'd be happy to